Hello everyone, welcome back to the channel. When you're starting out with GIS, one of the first things to get your head around is how geographic information is actually stored in the software. Whether you're using ArcGIS, QGIS, Google Earth, or any other mapping tool, all those different layers you see like roads, buildings, satellite images, land boundaries, or elevation maps aren't stored in the same way. Some layers are made up of precise shapes and features, while others are more like images made up of tiny pixels. Today, we're going to dive into the two main types of geospatial data you'll encounter, vector and raster. I'll also walk you through the most common file formats, what they're used for in real life, and the key differences between them, all explained in a straightforward, easy-to-understand way. GIS data is essentially a digital reflection of the real world around us. Think about everything we see and interact with: roads, rivers, buildings, even weather patterns like rainfall. All these can be captured as spatial information that GIS software can store, analyze, and display. The way this information is collected and how it behaves in space determines its data type. GIS primarily organizes data into two main structures. First, we have vector data, which uses points, lines, and polygons to represent discrete features with precise geometry, like the exact location of a building or the boundary of a park. Then there's raster data, which consists of pixels or grid cells. This is perfect for representing continuous surfaces such as satellite imagery or weather maps, where information changes smoothly across a landscape. Understanding these two types, vector and raster, is fundamental to working with any GIS project. Let's dive into vector data. This type of data is perfect for representing geographic features that have a clear and precise shape or boundary. Think of it as sketch-like elements on a map where each object is defined by exact geometry. Vector data is composed of three main components: points, lines, and polygons. Points represent specific locations. For example, the exact spots of buildings, survey markers, or points of interest on a map. They are like dots marking important single locations. Lines, on the other hand, represent linear features. These include roads and highways, rivers and streams, and utility networks like electric lines or pipelines, basically anything that stretches along a path. Lastly, polygons define areas. This could be parks, land use zones, county boundaries, or lake footprints. Polygons give us a way to represent spatial areas precisely. Altogether, vector data provides a clean and very accurate way to depict individual features on a map, making it extremely useful for detailed geographic analysis. Let's talk about the main vector file formats used in GIS. First, we have the file geodatabase with feature classes, which is ESRI's modern organized database system. Multiple layers like points, lines, and polygons can be stored within a single .gdb container. This format is efficient, portable between computers, and is the preferred choice for ArcGIS Pro projects. Next is the shapefile, a legacy but still very popular format. Consists of several files with the same name like .shop, .dbf, and .prj. Shapefiles are open source and can be easily shared between platforms like ArcGIS Pro and QGIS, despite some technical limitations. Then there are KML and KMZ formats, which are primarily used for Google Earth. These are great for visualizing and sharing features created in Google Earth applications. Finally, GeoJSON is widely used in web mapping and open-source GIS, especially for APIs and interactive maps. However, to perform detailed analysis in ArcGIS Pro, GeoJSON files typically need to be converted to feature classes. These four formats, file geodatabase, shapefile, KML/KMZ, and GeoJSON, are the key vector file formats that everyone starting with GIS should know. Now let's explore raster data, which is the second main type of geospatial data. Unlike vector data, raster data doesn't use points, lines, or polygons to represent features. Instead, it consists of a grid made up of many tiny cells or pixels, and each of these pixels holds a value. When these pixels come together, they form a continuous surface that can represent changes across an area seamlessly. This makes raster data perfect for capturing information like satellite imagery, which shows photos taken from satellites orbiting the Earth, or aerial photography, which involves high-resolution images captured from aircraft. Raster data is also essential for weather forecasting, as it allows us to represent temperature, rainfall, and other environmental factors continuously across large regions. Additionally, elevation models or digital elevation models, often called DEMs, use raster data to represent terrain surfaces and topography in great detail. Key idea is that with raster data, we're not focusing on distinct objects. Instead, we're working with comprehensive spatial surfaces that show gradual changes over space. So, whenever you encounter image-based GIS layers or environmental datasets that cover wide areas continuously, chances are you're dealing with raster data. Raster data comes in several different storage formats, each suited to specific needs. The most familiar ones are standard image files like JPG, PNG, and TIFF. These are the same types of images you get from phone cameras and scanners. TIFF, especially GeoTIFF, is crucial because it not only stores the image but also embeds geographic information, making it practical for mapping. In addition, raster datasets can be organized within a file geodatabase. This is particularly useful in ArcGIS, as it allows you to keep all your raster and vector data together in one place, streamlining project management. For weather and climate data, the NetCDF format is widely used. This specialized format holds complex atmospheric data such as temperature, precipitation, and wind patterns, which are essential for forecasting and climate modeling. On the web mapping front, we have tiled image services. These are pre-rendered image tiles designed to load quickly in browsers, enhancing the performance of online maps. Finally, ESRI's raster image services represent a newer approach. This cloud-based format allows raster data to be accessed and streamed through ArcGIS Online, offering flexibility and scalability as it continues to be developed. Understanding these formats is key when working with imagery and environmental data because each serves a particular purpose in storing, managing, and delivering raster information effectively. When deciding between vector and raster data, it's important to understand that each serves a different purpose and they complement each other in GIS work. Vector data is structured using points, lines, and polygons, which allow for precise representation of discrete features like roads, parcels, and buildings. This precision in coordinate geometry makes vector files generally smaller and highly accurate in defining boundaries. On the other hand, raster data is made up of a grid of pixels or cells, and it excels at representing continuous surfaces such as satellite imagery, digital elevation models, or weather patterns. While raster files can be quite large and are resolution dependent, they are invaluable for analyzing spatial phenomena that change gradually over space. So, rather than one being better than the other, professionals typically combine vector and raster data to leverage the strengths of both in comprehensive spatial analyses. To wrap up, GIS essentially converts real-world features into digital spatial layers, making complex geographic information easier to work with. These layers come in two main forms, vector and raster. Vector data is all about precision, using points, lines, and polygons to map specific objects accurately. On the other hand, raster data represents continuous surfaces through pixels, which is perfect for things like satellite imagery, elevation, and weather patterns. We also touched on important file formats, like shapefiles, which are still widely used for sharing data between software like ArcGIS and QGIS, as well as specialized raster formats that support advanced workflows involving terrain, weather, and web mapping. Understanding these basics is crucial because it sets the foundation for mastering more complex GIS tasks, whether it's mapping or spatial analysis. I hope this summary helped reinforce these key concepts in a clear and practical way.